Okay, in this video we are doing Calc AB Problem Set 44, problems and playlist in the description. Let's get started. So we have a graph of f prime and we want to answer the questions. So where is the function? I don't know why I'm struggling here. Where is f decreasing and why? Okay, so decreasing when f prime is negative. So there and there. So that's a bad color choice maybe, but from like 0 to 1.5 and then from 7 to 9. All right, so I'm gonna flip the way I usually write this because I do think I use like I use a more specific definition of increasing, decreasing. I think I always use strictly increasing and decreasing. So I tend not to include endpoints, but it is totally valid, I think, to include endpoints. So I'm gonna flip my description here and you can see what happens. So I'm gonna start with the fact that f prime is negative on certain intervals. So I'm gonna say, because f prime is less than 0 on 0, including 0, to 1.5, and 7 to 9, including 9. So I've started with that. I'm going to say f is decreasing on the closed interval 0 to 1.5 and 7 to 9. Totally valid to do that. I just typically use the strictly increasing idea, so I don't include endpoints, but I don't know. Some people definitely passionately feel like you should include them, so I wanted to do it that way just to show. I think the other way would be acceptable as well. Although I do think you should include 0, I do think you should include 9, no matter how you were doing this. The question is 1.5 and 7. I decided to include them here because it really does not matter in my mind if you include them or not. But anyway, on what intervals does the tangent line to the function f overestimate the true value of the function? So overestimates. Think of all the graphs you know. You want the tangent to overestimate it. So you need your graph to be concave down. So we need f to be concave down because that's where we will overestimate. And for f to be concave down, we need f prime to be decreasing. So we just look at f prime and we're like, where are you decreasing? So from 3 to 4 and then also from 6 to 8. And so I'm going to write up my explanation that way. I'm going to say the tangent overestimates on 3 to 4 and 6 to 8 because f prime is decreasing there. I think that's all you need. So notice I didn't talk about f double prime really in my description or my answer or my write-up. That's because I only have the graph of f prime. If I can base it on f prime, I'm going to do that because it's just less work, honestly. I don't have to connect f prime and f double prime and talk about all that stuff. Base it on f prime if you're given f prime, and you can do it, which you almost always can. All right, next up. Find the x-coordinates of the points of inflection of f and justify. So we know that the points of inflection occur at the relative extrema of f prime, so that'll be at 3, at 4, and at 6, and I'm just going to say because of the relative extrema, so let's do that. F has points of inflection at x equals 3, x equals 4, x equals 6, because f prime has relative extrema there. Good answer. Find the x-coordinates. It's like I'm telling myself I have a good answer. Yeah, good job, guy. X-coordinates of relative minimum, possibly minimums, and justify. So minimum will be where f prime goes from negative to positive. If you look at the graph, there's only one place that you go from negative to positive, really. It's at 1.5. So that's going to be our only answer. And the reason for that is that you bounce at 4. If f prime of 4 had been negative, then you would have ended up with 2 additional critical points, and one of them would have been a minimum, and blah, blah, blah. But it didn't happen, so whatever. So that's our only minimum, so let's write it up. F has relative minimum at x equals 1.5 because f prime changes negative to positive there. And that's what we got. All right, new question. Given f of 3 is 4, f prime of 3 is negative 6, g of 3 is 6, g prime of 3 is negative 2. Evaluate d dx, the derivative of f times g at x equals 3. So that's definitely the product rule. So let's do it. It's going to be first derivative of the second plus second derivative of the first. So this is literally the product rule. There aren't even expressions, so we don't have to do anything. We just write it down. We need to evaluate this at 3. So I'm going to plug in 3. I'm not going to make you watch that, but I've just show this line where I've plugged in 3 everywhere I see an x. Now we have to read off. So f of 3 is 4, g prime is negative 2, g is 6, and f prime is negative 6. All right, so we have negative 8, minus 36, negative 44, I think. I'm always a little not confident on these because I struggle sometimes with reading, reading the given and then substituting incorrectly. I know it's a weird thing to struggle with, but I do. So I think negative 44. If it's not that, let everybody know in the comments or whatever. All right. For b, we need to find the derivative of f over g. So this is a quotient, so we're going to use a quotient rule, and it's like a direct application of the quotient rule. So it's going to be bottom, g, derivative of the top, f prime, minus top, which is f, derivative of the bottom, g prime, all over the bottom squared, so g squared. All right, now we have to evaluate this at 3. I'm not going to make you watch me do that step, so I've replaced every x with a 3. Then we just, again, fill in the values. So we're going to get 6 times negative 6 minus 4 times negative 2 all over 6 squared. So that gives us negative 36 plus 8, which is negative 28 divided by 36. Both of those are multiples of 4, so whatever, divide out the 4 or whatever you do. So I get negative 7/9 as my final answer. That's the entire problem set. I hope you found this helpful, and good luck.